Hello again, it's another A-level maths video. We have started chapter 3 of the Pure Maths Year 1 textbook. This is section 3.1 where we're going to remind ourselves about simultaneous equations. Simultaneous equations, of course, if you are starting an A-level maths course, then you definitely have seen simultaneous equations before, and there's probably not going to be very much in this video which is going to be new to you. But this is really just a recap and reminding ourselves about some of the different ways we can approach these things. So anyway, question on the screen. I want you to solve these simultaneous equations, and I want you to pay attention to how you do it. What method would you use to solve these equations? Okay, so here are the equations. Now I hope that you got the answers x equals 4 and y equals 2. Those are the values, the pair of values, one for x and one for y, which make both of those equations true. But how did you do it? Because there are in fact two very common ways that people use to solve simultaneous equations like this. We can either solve them by elimination or by substitution. And I think that somebody doing an A-level maths course should know both methods here, because sometimes the elimination method is more efficient, sometimes the substitution method is more efficient. So let me show you what each of these methods entail. I'm sure you did one or the other, but do have a look and see what I'm doing here. So here is the equation we got here. Now, first of all, let me do it by elimination. And this is the method where we sort of try and combine the equations together in some way which eliminates one of the variables here. Now, what I'm going to do here, let's give these equations names. So if I call that one equation 1 and that one equation 2, if I double both sides of equation 2, I'm going to end up with this equation here, 4x minus 2y equals 6 times 2. Oops, almost forgot to double the 6 there. 6 times 2 is 12. And then that's going to combine very nicely with the other equation if I add them together, because if I add together the 2y here and the negative 2y here, those y's cancel out, they're eliminated, right? So the 5x plus the 4x here becomes 9x, 2y plus the negative 2y here, they cancel out each other out, and then we end up with 24 plus 12 is 36. And of course we can then see straight away, well, if 9x equals 36, then x has got to equal 4. We can take that 4, substitute it into either of these equations, and we find the value of y equals 2. So was that the way that you did it? Maybe you did it using substitution. So let's have a look and see if we can look at how it might be solved by substitution. So the idea of substitution when we're solving simultaneous equations is that you just rearrange one of the equations to make either x or y here the subject, and then substitute it into the other equation. So here maybe we could just kind of take this second equation. Again, let's just label them here. So I'm going to take my second equation here, rearrange it, and if I rearrange it and make y the subject, I'm going to say that y equals 2x minus 6 here. Can you see what I've done? Added y to both sides and subtracted 6 from both sides. Then what I can do is I can then substitute this wherever I see y in my other equation. So that means that if I then take equation 1, then that becomes 5x plus 2 lots of, and instead of writing y, I'm now going to write 2x minus 6 like that, and that's got to equal 24. Okay, so continuing with this then, I can sort of expand out the brackets and collect the terms. So I've got 5x plus 2 lots of 2x. 2 lots of 2x is of course 4x. So together I've got 9x here. 2 lots of the negative 6 here becomes minus 12. Okay, and then you can see I'm kind of in the same place as I was before. Add 12 to both sides, 9x equals 36, which then takes me to x equals 4. And then I can take that x equals 4 and substitute it back into either of these equations here to get my y value equals 2, just like with the elimination method. So have you seen both of those methods before? Are you familiar with both, or maybe you've only seen one of those methods before? I'd like you please to sort of consider both of those approaches whenever you're solving simultaneous equations like this, because sometimes one is more efficient than the other. So think about that with the question I've put on the screen. I've put some simultaneous equations on the screen, and I'm suggesting here that substitution might be a more efficient method than elimination for solving these equations. Stop the video and have a think about why that might be the case here. Okay, what's your thinking? Well, I'll tell you what I'm thinking. I'm thinking because we've already been given the second equation here as y equals something involving x. Y is already the subject here. It's really easy for us in this particular case to just take that y equals 5 minus 2x and substitute it into the first equation straight away. So we'd end up with 36 equals 3x plus 11 lots of 5 minus 2x. And then obviously we could continue from there. I won't actually do it now, but we could continue there, collect these x's together and work out what the value of x is, which would then lead us to the value of y. So that first step, because the y was already by itself here in this equation, it seems like the substitution method is the most efficient. Do you agree? Okay, what about this one then? Now, this one, I think actually the elimination method would be the one I would go for here. So have a look at the nature of what we've got on the screen there. Pause the video and have a think about why substitution might not be as efficient as elimination this time round. Okay, so what do you think here? Again, I'll share with you what I'm thinking. Looking at what we've got here, now there's no easy way, I think, of getting x or y by itself in either of these equations without introducing fractions. Can you see what I'm talking about here? So for example, if I took that first equation, 2x plus 3y equals 30. Now it doesn't matter if I choose to make x the subject or y the subject, so let's just choose to make x the subject here. I'm going to end up with some fractions being involved here because I'm going to end up with 30 minus 3y, and then we're going to end up with dividing both sides by 2 here. X equals, well, 30 divided by 2 is not too bad, but then we've got 3 over 2, lots of y here. We've got a fraction here. Now, of course, as A-level mathematicians, we can cope with fractions, but hey, we'd rather not, right? So perhaps an elimination method would be the more efficient way of dealing with this one. Okay, now we're going to finish off this video. Just I want to show you something on your calculator which you can do here because your calculator has a wonderful simultaneous equation solver on it. Did you know that? Well, there it is. I want to quickly show you how that works here. So what we need to do is we need to go into the menu and we need to go down to option A, I think it is, which is right there, the equation. So remember this one because this is the same option for quadratics, except this time we'll choose the simultaneous equation option there. In this particular case, we'll just have two equations in two unknowns. So your calculator cuts up to 4 here. And what we'll do is we will have a look at the question that we actually started off with here. We already know the answer because we worked it out, but let's show you how it works on the calculator here. So we've got coefficients here, 5x, 2y, there we go, equals 24. And then we'll put in our next equation here, which is 2x minus 1 lot of y here. So minus 1 is what I need to put in the coefficient there. That equals 6. And then if I press equals again, you'll see it will do the calculations. And there we've got x equals 4, press equals one more time, and we've got y equals 2 there like that. So why don't you have a go at making sure you can use that function on your calculator? And I've put a simultaneous equations on the screen here, which are a bit more complicated, where you wouldn't really want to use either the substitution or the elimination method here. So see if you can use your calculator to get an answer for that one, please. Okay, so did you use your calculator? And if you did you get these answers? You should have got x equals minus 7.4 and y equals minus 4.9 as your solutions there. Of course, you may have got them as fractions, so if you did, minus 37 over 5 would be your x value, and minus 49 over 10 would be the y value. Okay, anything in that video you haven't seen before? maybe how to use the calculator, but if you want to get a bit more practice, and there's some slightly more complicated questions in this exercise, please do consolidate this work by looking at exercise 3A of the textbook on page 40. But that's it for now, and I'll see you again next time.